Good morning, everyone. I, Aditya from BSc Chemistry Honors Final Year, is today here to prepare the audio presentation for the visually impaired students. My topic of the presentation is drugs. Drugs are the chemicals of low molecular masses ranging from 100 to 500 micromillimeter. These interact with the macromolecular targets and produce a biological response. When the biological response is therapeutic and useful, these chemicals are called medicines, and most of are used in the diagnosis, prevention, and the treatment of diseases. Most of the drugs used as the medicines are potential poisons if taken in doses higher than that recommended. Use of chemical therapeutic effect is known as chemotherapy. The classification of drugs. The drugs can be classified on the criteria outlined as follows. On the basis of pharmacological effect. This classification is based on the pharmacological effect of the drugs. It is useful for the doctors because it provides them the whole range of drugs are available for the treatment of a particular type of problem. For example, analgesics having the pain killing effect, antiseptics kills or arrest the growth of microorganisms. Second type of classification is on the basis of the drug's action. It is based on the action of a drug on a particular biochemical processes. For example, all antihistamines inhibit the action of compound histamine which causes inflammation in the body. There are various ways in which the action of histamines can be blocked. You will learn about this in section 16.3.2. On the third type of classification is the on the basis of chemical structure. It is based on the chemical structure of a drug. Drugs classified in this way share common structural features and often have similar pharmacology activity. For example, sulfonamides have common structural feature given below, having attached NH2 group and SO2 NHR group in the following para positions. Fourth type of classification is on the basis of molecular targets. Drugs usually interact with the biomolecules such as carbohydrates, lipids, proteins, and nucleic acids. These are called target molecules or drug targets. Drugs possessing some common structural features may have the same mechanism of action on the targets. The classification based on the molecular targets is the most useful classification for the medicinal chemist. Now let's see what is drug target interaction. Macromolecules of biological origin perform various functions in the body. For example, proteins which perform the role of biological catalyst in the body are called enzymes. Those which are crucial to communication system in the body are known as receptors. Carrier proteins carry polar molecules across the cell membrane. Nucleic acids having the coded generic information for the cells. Lipid and carbohydrates are the structural part of the cell membrane. We shall explain the drug target interaction with the example of enzymes and receptors. First one is catalytic action of enzymes. For understanding the interaction between a drug and an enzyme, it is important to know how do enzymes catalyze the reaction. In their catalytic activity, enzymes perform two major functions. The first function of an enzyme is to hold the substrate for a chemical reaction. Active site of enzymes hold the substrate molecule in a suitable position so that it can be attacked by the reagent effectively. Substrates bind to the active site of the enzyme through a variety of interactions such as ionic bonding, hydrogen bonding, van der Waal interaction, or dipole-dipole interaction. Here you can see in the figure there is an enzyme having the active site vacant and second one is substrate, and in the third step the enzyme is holding the substrate. The second function of an enzyme is to provide functional groups that will attack the substrate and carry out the chemical reactions. Second one is drug enzyme interaction. Drugs inhibit any of the mentioned activities of the enzymes. These can block the binding site of enzyme and present out the binding of substrate, or can inhibit the catalytic activity of the enzyme. Such drugs are known as enzymes inhibitors. Drug inhibit the attachment of the substrate on the active site of enzyme in two different ways. First one is the drugs compete with the natural substrate for their attachment on the active site of enzymes. Such drugs are known as competitive inhibitors. Second one are those some drugs are not bind to the enzyme's active site. These bind to a different site which is known as allosteric site. This binding of the inhibitor at allosteric site changes the shape of the active site in the shape of that substrate cannot recognize it. If the bond formed between the enzyme and inhibitor, a strong covalent bond and cannot be broken easily, then the enzyme is blocked permanently. The body then degrades the enzyme inhibitor complex and synthesizes the new enzyme. Receptors as the drug targets. Receptors are the proteins that are crucial for the body's communication processes. Majority of these embedded in the cell membranes generally. Receptor proteins are embedded in the cell membrane in such a way that their small part possessing active site projects out of surface of the membrane and opens on the outside region of the cell membrane. Animal cell. Here you can see at a specific small part of the cell membrane that is usually defined as plasma membrane, the outer surface of the cell membrane, and there is a binding site of the receptors. In the interior of cell there is inner surface of a cell membrane. In the body, the message between two neurons and that between neurons to muscles is communicated through the certain chemicals. These chemicals are known as chemical messengers and are received at the binding sites of receptor proteins. To accommodate a messenger, shape of the receptor site changes. This brings about the transfer of message into the cell. Thus, chemical messenger give message to the cell without entering the cell. There are large number of different receptors in the body that interact with the different chemical messengers. These receptors show selectivity for one chemical messenger over the other because their binding sites have different shape, structure, and amino acids preparation. Drugs that bind to the receptor site and inhibit its natural function are called as antagonists. These are useful when blocking of the message is required. There are other type of drugs that mimic the natural messenger by switching on the receptor. These are called agonists. These are the useful when there is a lack of natural chemical messenger. Now, in this section, we will discuss about the therapeutic action of a few important classes of drugs. Overproduction of acid in the stomach causes irritation and pain. In severe cases, ulcers are developed in the stomach. Until 1970, only treatment for acidity was the administration of antacid, such as sodium hydrogen carbonate or a mixture of aluminium and magnesium hydroxide. However, excessive hydrogen carbonate can make the stomach alkaline and trigger the production of even more acid. Metal hydroxides are better alternative because of being insoluble. These do not increase the pH above neutrality. These treatment control only the symptoms and not the cause. Therefore, with these metal salts, the patients can't be treated easily. In the advanced stages, the ulcers become life threatening, and its only treatment is the removal of the affected part of stomach. Now, a major breakdown in the treatment of hyperacidity came through the discovery according to which a chemical histamine stimulates the secretion of pepsin and hydrochloric acid in the stomach. The drug cimetidine, that is Tegamet, was designed to prevent the interaction of histamine with the receptor present in the stomach wall. This resulted in the release of lesser amount of acid. The importance of the drug was so much that it remained the largest selling drug in the world until another drug, that is Rentidine Zentec, was discovered. Here we can see the structure of histamine, cimetidine and ranitidine. Now see what are antihistamines. Histamine is a potent vasodilator. It has the various function. It contracts the smooth muscles in the bronchi and gut, relaxes other muscles such as in the muscles of the fine blood vessels. Histamine is also responsible for the nasal congestion associated with the common cold, allergic response to the pollen. Synthetic drugs brompheniramine, dimetapp, and terifenadine Saladin act as the antihistamines. They interfere with the natural action of the histamine by competing with the histamine for binding sites of receptors where histamine exerts its effect. Now the question is that arises is why do we mentioned antihistamines not affect the secretion of acid in the structure in the stomach? The reason is that anti-allergic and antacid drugs work on the different receptors. Now see neurological active drugs. First one are the tranquilizers. Tranquilizer and analgesics are neurological active drugs. These affect the message transfer mechanism from nerve to receptor. Tranquilizer are the class of chemical compound used for the treatment of stress and mild or even severe mental diseases. These relieve anxiety, stress, irritability, or excitement by inducing a sense of well-being. They form an essential component of the sleeping pills. There are various type of tranquilizers. They function by different mechanism. For example, noradrenaline is one of the neurotransmitters that play a role in the mood changes. If the noradrenaline is low for some reason, then the signing sending activity becomes low and the person suffers from depression. In such a situation, antidepressant drugs are required. These drugs inhibit the enzymes which catalyze the degradation of noradrenaline. If the enzyme is inhibited, this important neurotransmitter is slowly metabolized and can activate its receptor for longer periods of time, thus counteracting the effect of depression. Ironizid and the phenelzine are two such drugs. Some tranquilizers, namely chlordiazepoxide and meprobamate, are relatively mild tranquilizers suitable for the relieving tension. Inequalin is used in controlling the depression and hypertension. Derivatives of barbituric acid, that is veranol, amytal, nembutal, luminal, and second, constitute an important class of tranquilizers. These derivatives are called barbiturates. Barbiturates are the hypertonic, that is sleep producing agents. Some other substances used as tranquilizers are Valium and serotonin. Now see the next class, that is analgesics. Analgesic reduce or abolish pain without causing impairment of consciousness, mental confusion, incoordination or paralysis or some other disturbances of nervous system. These are classified as non-narcotic, analgesic and narcotic drugs. Non-narcotic or non-additive analgesics are the aspirin and paracetamol belong to this category. Aspirin is the most familiar example. It inhibits the synthesis of the chemicals known as prostaglandins, which stimulate the inflammation in the tissue and cause pain. These drugs are effective in relieving the skeletal pain, such as due to the arthritis. These drugs have many other effects, such as reducing fever, that is antipyretic, and preventing platelet coagulation. Because of this anti blood clotting action, aspirin finds the use in the prevention of heart attacks. Narcotic analgesics, morphine and many of its homologs, when administered in the medical doses, relieve pain and produce sleep. In poison doses, they produce stupor, coma, convulsions, and ultimately death. Morphine narcotics are sometimes referred to as opiates since they are obtained from the opium poppy. These analgesics are chiefly used for the relief of postoperative pain, cardiac pain, and the pains of terminal cancer and in childbirth. Now see the next class, that is antimicrobials. Diseases in human beings and animal may be caused by a variety of microorganisms such as bacteria, fungi, virus, and other pathogens. An, an antimicrobial tends to destroy and prevent development or inhibit the pathogenic action of the microbes such as bacteria to the antibacterial drugs, fungi to the antifungal drugs, virus to the antiviral agents, or other parasites, that is antiparasitic drugs selectively. Antibiotics, antiseptics, and disinfectants are the antimicrobial drugs. Antibiotics are the used as drugs to treat the infections because of their low toxicity for the humans and animals. Initially, antibiotics were classified as chemical substance provided by the microorganisms that inhibit the growth or even destroy microorganisms. The development of synthetic methods has helped in synthesizing some of the compounds that were originally discovered as the product of microorganisms. Also, some purely synthetic compounds have antibacterial activity and therefore definition of antibiotic has been modified. An antibiotic is now refers to a substance produced wholly or partially by the chemical synthesis which is in low concentration and inhibits the growth or destroy the microorganisms by intervening in their metabolic processes. The search for chemicals that would adversely affect invading bacteria but not the host began in the 19th century. Paul Herrlich, a German bacteriologist, conceived his idea. He investigated arsenic based structure in order to produce less toxic substance for the treatment of syphilis. He developed the medicine named arspheniamine known as Salvarsan. Paul Ehrlich got Nobel Prize for Medicine in 1908 for his discovery. It was the first effective treatment discovered for syphilis. Although Salvarsan is toxic to human beings, its effect on the bacteria spirochete which causes syphilis is much greater than on human beings. At the same time, Ehrlich was working on the azodize also. He noted that there is a similarity in the structure of Salvarsan and azodize. The AS double bond AS linkage present in aspharenamine resembles that in the linkage in the azodize, in the sense that arsenic atom is present in the planes of nitrogen atom. He also noted that the tissues get colored by the dye selectively. Therefore, Ehrlich began to search for the compounds which resembled in structure to azodize and selectively bind to bacteria. In 1932, he succeeded in preparing the first effective antibacterial agent, that is Prontosil, which resembles in the structure to the compound Salvarsan. Soon it was discovered that in the body Prontosil is converted to a compound called sulfanylamide, which is a real active compound. Thus, the sulfa drugs were discovered. A large range of sulfonamide